Hi, you're welcome. Today we'll be looking at equation of a matrix, and the general formula for finding the equation of a matrix is always given by the transpose of x multiplied by the matrix A multiplied by x itself. So here we are representing x by x1, x2, x3, which is a 3 by 1 matrix, while the transpose of x will be a 1 by 3 matrix, x1, x2, x3. And then also the matrix A will be given by a 3 by 3 matrix, which we are assuming by A11, A12, A13, all down to A33. So the first step we get to take is to find AX. That's multiplying the matrix A by the matrix X. That's the 3 by 3 matrix multiplied by a 3 by 1 matrix. And when you multiply that, you're saying A11 multiplied by X1 plus A12 multiplied by x2 plus A13 multiplied by x3, and that's how we come across this. That's the same way we also did to get these values and these values, making it a 3 by 1 matrix. Then the next thing we get to do is to then bring in the transpose of x, multiplying it by this matrix here. So once we get that, the next step we take, x1 will be multiplying the entire row here, x2 will be multiplying the entire row here, and x3 will be multiplying the entire row here. That was how we came across this, x1 multiplied by a11, x1, and then we came across this value. Then when we get that, we get to open the bracket by multiplying x1 by the values in it. So x1 multiplied by x1 a11 gives us a11 x1 squared, and then we get to the answer, this. So here in this aspect, where we get to find a12 plus a21, it's this way because a12 and a21 actually are the same. A12 equals to a21, so we get to represent it by h. So if we say h plus h, we are having 2h. That is the reason why we come here and we get our general formula as ax1 square plus b this, and we have 2h x1 x2 plus 2f x2 x3 plus 2j x1 x3. This is the general formula of the equation of a matrix. So let's try an example of a 3 by 3 matrix given by 2, 1, minus 3. Now if you look at this, you find out that here this is a12, this is a12, this is a21. You can see that they are of the same. That was the reason why we represented by h, represented by f in the previous in the functions below here. So we come down again, you see here this is a13, this is a31. You see minus 3, the same. This is a23, this is a32. You see they are the same, 3, 3. That is the reason why we got to represent it by f, represented it by g, and represented by h. So now we also applied the same formula here, x transpose t, the transpose of x multiplied by the matrix A multiplied by x, where x is x1, x2, x3. The transpose is a 1 by 3 matrix, x1, x2, x3. So when we multiplied this together, we got this 2 times x1 plus 1 times x2 plus minus 3 by x3. And then we came across this matrix here. Then we brought in the transpose of x. We got this, and then x1 will be multiplying everything here, x2 will multiply everything here, and x3 will multiply everything here. So if you then apply your multiplication rules and you collect the like terms, you're going to get an answer like this: 2x1 squared minus 2x2 squared plus 4x3 squared. So this will be the equation, the quadratic form, this is going to be the quadratic form of this matrix that has been given up here. This will be the quadratic form. Then if we look at the 2 by 2 matrix also, it's the same format we get to make use of. Do this, we bring the transpose AX, we also come down here where we have X equals to A1 X2, then we also have the A transpose of X. We multiply A by X, we get X1 plus 2X2, 2X1 plus 9X2, and then we bring in the transpose of X, we multiply it by this matrix we've gotten here, then we come down to our answers, multiplying this by all true plus X2 multiplying by all true, and then when we come around we get the final answer as this. So this is going to be the quadratic form of the matrix, the 2 by 2 matrix, which is x1 x2 plus 9x2 squared plus 4x1 x2. Thank you very much.